Okay, so what you see in front of you is a blank Excel screen, and the only thing is I have inserted the picture of our model that we just developed, so that we know what we have to translate this into a model here, and then call Excel Solver and get the numerical solution. So there are several options for doing this, two options for doing this. One is to create a different form for every linear programming, for every time that we have a formulation like this that we have to translate, create a new way of setting up the cells. And that's probably what you'd end up doing if you have an application at work. But here we will be formulating a lot of problems, and we don't want to spend a lot of time deciding where our cells should go. So I'm suggesting a general form. And the form generally has the variables across on the columns, and has the constraints down the rows. So we, as a standard thing, we give an entry for variable. So this is where our variable names will be. Okay, I'll take mine. Okay, and the variable names will be x1 and x2. I could use tables and chairs, but that's also a choice you have to make, whether you use the names of your model or whether you use common English names, and that's really up to you. Generally, I'll be using the nomenclature, the symbols that I've used in the formulation. So those are the variables. And I have the values. I have to leave a place for Excel Solver can then tell me what the answer is. So this is where the answer is going to be in terms of the number of chairs and number of tables. Besides the constraint, there's also the objective. So I'll put down the objective here, objective row. And I'll put a constraint for the, well, since I didn't give a name for the constraint, I'll call it the lathe and the drill. And we need some additional columns. This is a standard notation. I'll call this also the objective, but also the left-hand side, because the left-hand side of the constraint is going to go in this entry. So I will be calculating the left-hand side of the constraint. I'll also be putting down the value, a place for the right-hand side of the constraints. So we'll put the RHS, right-hand side, in here. So for the objective function, we have the coefficients. So we put the coefficients here. This is 1, this is 2, and then here we have to use, you cannot just take this cell and times that cell plus that cell. Do it the slow way. You should use the sum product function. And for years I did not use the sum product function, and for any size model it would slow down to a grinding halt until I called Solver frontline, which makes this add-in, and I asked them about it, and they said you got to use the sum product. So we're going to use the sum product, which is these two here, and then a comma times these two cells here, and then we close the bracket, and then we have it. So it's 0, because right now if we had a 1 and a 1 here, then I would have a 3, and that checks that out. You may want to put something in there. It's up to you. Now we get to there's no right hand side, so there's no entry here. Eventually we want to, well, let's enter the data here. For the lathe, it's going to be a 1 and a 3 and a 1 and a 1. And the right hand sides are going to be 16 and sorry, 7. Okay. Now I do want, in general, to drag this equation down, copy it to the below, but I can't do that because then it's going to use relative location. So I want to make sure that the second row is always used. So I put $1 in front of the 2, $1 in front of the 2, and then I can just drag that down, which gives me the correct left-hand side, as you can note here for those particular entries. that is it for the data. Now we need to bring in solver. So for solver, we go to data, and we don't see solver here anywhere. And so we need to, we need to activate it. And the first time, this only needs to be done once. You need to go to File. You need to go to Options. Under Options, you need to go to Add-ins. Under Add-ins, you notice that the active application add-ins is only the Acrobat PDF Maker. The inactive one includes a whole bunch, includes the solver add-in as well. And that is an Excel add-in. And so we need to have Excel add-ins. You need to make sure that the entry where the type matches the one. So we need the Excel add-in as it was. And we say go. As soon as we go, it shows me this window, and I say I want the solver add-in. I say okay. I wait a little bit, and now I go to data, and it shows me the solver. So I now click on the solver, and let me bring it down here. One of the things is set objective. So I got to set the objective. The objective is right here. So it's D3, and I want to maximize it. And I need to change the variables, and I need to highlight the variables that need to be changed. Those are the variables that need to be changed. And then the constraints, I need to add constraints. And the constraints are that the left-hand sides, which are these two, have to be less than or equal to the right-hand sides, which are these two. And that's it. I need to change the select the solving method. We're going to pick linear programming, simplex LP. And we make the unconstrained variables non-negative, so I don't have to specify that x1 and x2 have to be non-negative. And now I'm ready to solve, and I go here and I highlight the solve. And the solver found the solution, and it tells me that make 2.5 chairs and 4.5 tables, and you may say, well, it doesn't make sense to make 2.5 chairs and 4.5 tables. We'll get that the day after tomorrow. We'll be dealing about integer programming. But for now, we allow these to be real. So that's why I said think of it in terms of making like 2,500 chairs and 4,500 tables, just so to not face that problem that these are not integer. This is the end of this video, and it shows you how we get the results.